The second principle of the assertion-evidence approach is that you should support your messages with visual evidence, not bullet points. That visual evidence could be photos, drawings, diagrams, or graphs. So what is the advantage of including images into a scientific talk? As mentioned in an earlier film, the psychology researcher Alan Pivio found that both written words and spoken words are processed in the same part of the brain. What Pivio also found was that images are processed in a different part of the brain. In other words, you can readily process images while someone is speaking. Building on Pivio's work, many researchers, including Richard Mayer from the University of California at Santa Barbara, have experimented with the effect of including images in informative presentations. The big takeaway from this work is that audiences learn much more deeply from words and relevant images than from words alone. For that reason, when crafting presentations, you want to include relevant images for deeper learning. Although incorporating relevant images into your visual evidence requires more imagination and work than writing a bulleted list, the extra effort is worth it, as you can see from how well the examples in the following films communicate the content.
So next, let's talk about that main concern people had, which was the range. In a survey done by plugincars.com, they asked people, what number would the range of a car have to hit for you to consider it acceptable? What's the magic number of miles it has to be able to drive on a single charge for you to buy it? And they found that most of the responses ranged anywhere from 100 to 200 miles, with the average being right in the middle of about 150 miles. So here on the map, we have displayed the driving range of 150 miles from our home here, right in Happy Valley. As you can see, you can get just up to Scranton, and a little bit into southern New York. We're just past Pittsburgh, a little bit into West Virginia. Pretty good range. You can reach a lot of places, and this is 150 miles. Now, currently, the minimum range offered by the Model S is 230 miles, displayed in green here. You can see now we're way past Buffalo, we're easily past Pittsburgh, getting into Ohio, we're into West Virginia now, way beyond that 150-mile range that people wanted. And even additionally, Elon Musk, the CEO of Tesla Motors, predicts that this range is going to increase from about 5 to 10% every single year as they continue to innovate their battery technologies.
Now, let's look at the incorporation of a graph.
This graph provided to me by Dr. Valago shows that this F-stand actually does work. The x-axis represents the amount of time that a sample of water was run through the sand, while the y-axis represents the amount of particles remaining in that sample of water. As you can see with bare sand, no matter how long you run bare sand through water, the water will still have all those particles. Nothing will be taken out. However, the longer that you run water through the F-sand, the more particles and bacteria are taken out of it, as you can see by the exponentially negative decrease in the graph. This shows that this sand actually does work and does purify the water without any organic matter in it.
Now, let's look at the incorporation of a diagram.
So if you have some cost function and it has a maximum at the yellow star, that's what we're trying to reach. But you don't know anything about what this function looks like, and you're operating at that red X, so that would be suboptimal. You're not getting as much power as you could be. What extremum seeking does is it perturbs the system around the operating point, and to get those perturbations, they call it a dither. You just add a small sine wave to the system to kind of check what the performance is like to the left and the right of your operating point. Then you use some filters to kind of approximate the gradient of the system. So using the left and right data, you can see what does that gradient of the system look like. And then using gradient descent, you just climb a little bit higher towards the optimum. This process repeats itself over and over and over again until you reach the optimum, at which point you are oscillating around it.